This is 7C. We are looking at the right triangle that's embedded in a circle. Now, the information we've been given is this hypotenuse, and we've been given the sine ratio. So since I've been given the sine ratio, I'm going to find out the opposite side length. So I'm going to take a look at this diagram, and I'm going to find that length here, the opposite length. And I'm going to just call that y. Okay, because it happens to be the vertical positioning in this xy plane, so I'll just call that y. And I know that the sine ratio is equal to 0.5, and I'm going to write that as 1/2, and that ratio is equivalent to y over 20. And I can just solve this value for y. I can solve it as a proportional equation. I can solve it algebraically as well. So this is going to be 20 divided by 2, and that side length is going to be equal to 10. Using Pythagoras then, I can find out this length here, which I'm going to call x. And I know that x squared is equal to the hypotenuse squared minus the shorter length square. So x squared is going to be 400 minus 100, which is 300. So x, when I square root this, is going to end up being 10 square root 3. That's the exact value. This is approximately 17.3 units long. And that's about right. So this is, my hypotenuse is 20, the horizontal length is 17.3, and the vertical length is 10. So then what I'm left to find are my ratios and my angle. So I'm going to find the cosine ratio, and I'm going to write this as 10 root 3. Now this happens to be a special triangle, so when we work out the angle, we're going to see that it works out to a special angle. But without that, I can still work out the cosine ratio. It's going to be the adjacent side, 10 root 3 over the hypotenuse is 20, so that simplifies to root 3 over 2, and is a decimal value that works out to be about 0.866. Okay, so I'm just going to start filling in these things here. So this is going to be 10 root 3. That's approximately equal to 17.3. This is exactly 10. And then the tan ratio, I'm going to write that as rise over run. That will simplify to 1 over root 3. And the tan ratio, this as a decimal value, is about 0.577. So I've got my sine, tan, I've got all my sides. Now at this point I need to solve for the angle theta, and I can use an inverse function to solve for angle theta. So I can take the inverse of the ratio 0.5, so the inverse sine of 0.5. On my calculator, it's going to give me exactly 30 degrees. And we can actually do this one without a calculator, because since we should know this ratio of 1 to 2 in a 30-degree triangle, we could have done this without a calculator as well.